Welcome to our video on machine learning with Python. In this introduction, we'll explore how Python, with its powerful libraries and ease of use, has become a go-to language for machine learning. We'll cover the basics, highlight key libraries like scikit-learn and TensorFlow, and demonstrate how to build and deploy your own machine learning models. Whether you're a beginner or looking to enhance your skills, this video will guide you through the essential steps to start your machine learning journey with Python. Topics to be covered here. Introduction to machine learning, supervised learning, unsupervised learning, Python libraries for machine learning. The capability of artificial intelligence systems to learn by extracting patterns from data is known as machine learning. Machine learning is an idea to learn from examples and experience, without being explicitly programmed. Instead of writing code, you feed data to the generic algorithm, and it builds logic based on the data given. Python is a popular platform used for research and development of production systems. It is a vast language with number of modules, packages, and libraries that provides multiple ways of achieving a task. Python and its libraries like NumPy, Pandas, SciPy, scikit-learn, Matplotlib are used in data science and data analysis. They are also extensively used for creating scalable machine learning algorithms. Python implements popular machine learning techniques such as classification, regression, recommendation, and clustering. Python offers ready-made framework for performing data mining tasks on large volumes of data effectively in lesser time. What is machine learning? Data science, machine learning, and artificial intelligence are some of the top trending topics in the tech world today. Data mining and Bayesian analysis are trending, and this is adding the demand for machine learning. Machine learning, study of algorithms that improve their performance at some task with experience. Machine learning is a discipline that deals with programming the systems so as to make them automatically learn and improve with experience. Here, learning implies recognizing and understanding the input data and taking informed decisions based on the supplied data. It is very difficult to consider all the decisions based on all possible inputs. To solve this problem, algorithms are developed that build knowledge from a specific data and past experience by applying the principles of statistical science, probability, logic, mathematical optimization, reinforcement learning, and control. ML machine learning, ML, is an automated learning with little or no human intervention. It involves programming computers that have to learn from the available inputs. The main purpose of machine learning is to explore and construct algorithms that can learn from the previous data and make predictions on new input data. Growth of machine learning is preferred approach to speech recognition, natural language processing, computer vision, medical outcomes analysis, robot control, computational biology. This trend is accelerating improved machine learning algorithms, improved data capture, networking, faster computers, software too complex to write by hand, new sensors/I/O devices, demand for self-customization to user environment. It turns out to be difficult to extract knowledge from human experts, failure of expert systems in the 1980s. Applications of machine learning algorithms. The developed machine learning algorithms are used in various applications such as web search, computational biology, finance, e-commerce, space exploration, robotics, information extraction, social networks, debugging, data mining, expert systems, vision processing, language processing, forecasting, things like stock market trends, weather pattern recognition, games. Benefits of machine learning: powerful processing, better decision-making and prediction, quicker processing, accurate, affordable data management, inexpensive analyzing complex big data. Steps involved in machine learning. A machine learning project involves the following steps: defining a problem, preparing data, evaluating algorithms, improving results, presenting results. Magic? No, more like gardening. Seeds equals algorithms, nutrients equals data, gardener equals you, plants equals programs. So what the machine learning is? Automating automation, getting computers to program themselves. Writing software is the bottleneck, let the data do the work instead. Machine learning techniques given below are some techniques in this machine learning tutorial. Classification, categorization, clustering, trend analysis, anomaly detection, visualization, decision making. ML in a nutshell, machine learning is a subset of artificial intelligence where computer algorithms are used to autonomously learn from data and information. Machine learning computers can change and improve their algorithms all by themselves. Tens of thousands of machine learning algorithms. Every machine learning algorithm has three components: representation, evaluation, optimization. Representation, decision trees, sets of rules/logic programs, instances, graphical models, neural networks support vector machines, SVM, model ensembles. Evaluation, accuracy, precision and recall, squared error, likelihood, posterior probability, cost/utility margin, entropy, KL divergence. Optimization, combinatorial optimization e.g. greedy search, convex optimization e.g. gradient descent, constraint optimization e.g. linear programming. Features of machine learning. Let us look at some of the features of machine learning. Machine learning is computing intensive and generally requires a large amount of training data. It involves repetitive training to improve the learning and decision-making of algorithms. As more data gets added, machine learning training can be automated for learning new data patterns and adapting its algorithm. Machine learning algorithms. Machine learning can learn from labeled data, known as supervised learning, or unlabeled data, known as unsupervised learning. Machine learning algorithms involving unlabeled data, or unsupervised learning, are more complicated than those with the labeled data or supervised learning. Machine learning algorithms can be used to make decisions in subjective areas as well. Examples: logistic regression can be used to predict which party will win at the ballots. Naive Bayes algorithm can separate valid emails from spam. Face detection, identify faces in images, or indicate if a face is present. Email filtering, classify emails into spam and not spam. Medical diagnosis, diagnose a patient as a sufferer or non-sufferer of some disease. Weather prediction, predict, for instance, whether or not it will rain tomorrow. Concepts of learning. Learning is the process of converting experience into expertise or knowledge. Learning can be broadly classified into three categories, as mentioned below, based on the nature of the learning data and interaction between the learner and the environment. Supervised learning, unsupervised learning, semi-supervised learning. Types of learning: supervised, inductive, learning. Training data includes desired outputs. Unsupervised learning. Training data does not include desired outputs. Semi-supervised learning. Training data includes a few desired outputs. Reinforcement learning, rewards from sequence of action. Similarly, there are four categories of machine learning algorithms as shown below: supervised learning algorithm, unsupervised learning algorithm, semi-supervised learning algorithm, reinforcement learning algorithm. Supervised learning. A majority of practical machine learning uses supervised learning. In supervised learning, the system tries to learn from the previous examples that are given. On the other hand, in unsupervised learning, the system attempts to find the patterns directly from the example given. Speaking mathematically, supervised learning is where you have both input variables, x, and output variables, y, and can use an algorithm to derive the mapping function from the input to the output. The mapping function is expressed as y equals f, x. When an algorithm learns from example data and associated target responses that can consist of numeric values or string labels, such as classes or tags, in order to later predict the correct response when posed with new examples, comes under the category of supervised learning. This approach is indeed similar to human learning under the supervision of a teacher. The teacher provides good examples for the student to memorize, and the student then derives general rules from these specific examples. Categories of supervised learning. Supervised learning problems can be further divided into two parts, namely classification and regression. Classification. A classification problem is when the output variable is a category or a group, such as black or white or spam and no spam. Regression. A regression problem is when the output variable is a real value, such as rupees or height. Unsupervised learning. In unsupervised learning, the algorithms are left to themselves to discover interesting structures in the data. Mathematically, unsupervised learning is when you only have input data, x, and no corresponding output variables. This is called unsupervised learning because unlike supervised learning above, there are no given correct answers and the machine itself finds the answers. Unsupervised learning is used to detect anomalies, outliers, such as fraud or defective equipment, or to group customers with similar behaviors for a sales campaign. It is the opposite of supervised learning. There is no labeled data here. When learning data contains only some indications without any description or labels, it is up to the coder or to the algorithm to find the structure of the underlying data, to discover hidden patterns, or to determine how to describe the data. This kind of learning data is called unlabeled data. Categories of unsupervised learning. Unsupervised learning problems can be further divided into association and clustering problems. Association. An association rule learning problem is where you want to discover rules that describe large portions of your data, such as people that buy X also tend to buy Y. Clustering. A clustering problem is where you want to discover the inherent groupings in the data, such as grouping customers by purchasing behavior. Reinforcement learning. A computer program will interact with a dynamic environment in which it must perform a particular goal, such as playing a game with an opponent or driving a car. The program is provided feedback in terms of rewards and punishments as it navigates its problem space. Using this algorithm, the machine is trained to make specific decisions. It works this way: the machine is exposed to an environment where it continuously trains itself using trial and error method. Here learning data gives feedback so that the system adjusts to dynamic conditions in order to achieve a certain objective. The system evaluates its performance based on the feedback responses and reacts accordingly. The best-known instances include self-driving cars and chess master algorithm AlphaGo. Semi-supervised learning. If some learning samples are labeled, but some other are not labeled, then it is semi-supervised learning. It makes use of a large amount of unlabeled data for training and a small amount of labeled data for testing. Semi-supervised learning is applied in cases where it is expensive to acquire a fully labeled dataset while more practical to label a small subset. For example, it often requires skilled experts to label certain remote sensing images, and lots of field experiments to locate oil at a particular location, while acquiring unlabeled data is relatively easy. Here an incomplete training signal is given, a training set with some, often many, of the target outputs missing. There is a special case of this principle known as transduction, where the entire set of problem instances is known at learning time, except that part of the targets are missing. Categorizing on the basis of required output. Another categorization of machine learning tasks arises when one considers the desired output of a machine-learned system. Classification. When inputs are divided into two or more classes, and the learner must produce a model that assigns unseen inputs to one or more, multi-label classification, of these classes. This is typically tackled in a supervised way. Spam filtering is an example of classification, where the inputs are email, or other, messages, and the classes are spam and not spam. Regression, which is also a supervised problem, a case when the outputs are continuous rather than discrete. Clustering, when a set of inputs is to be divided into groups. Unlike in classification, the groups are not known beforehand, making this typically an unsupervised task. Libraries and packages. To understand machine learning, you need to have basic knowledge of Python programming. In addition, there are a number of libraries and packages generally used in performing various machine learning tasks as listed below. NumPy is used for its n-dimensional array objects. Pandas is a data analysis library that includes data frames. Matplotlib is 2D plotting library for creating graphs and plots. Scikit-learn, the algorithms used for data analysis and data mining tasks. Seaborn, a data visualization library based on Matplotlib.